everyone, and welcome to this video presentation of my multi-modal sentiment analysis system. Traditional sentiment analysis typically relies on single input modality, analyzing at a text, reviews, or product images in isolation. However, modern digital content, such as social media posts, advertising, and user-generated reviews, is naturally multimodal. A user might write a sarcastic comment alongside a happy picture or write a neutral statement referencing highly negative image. To solve this project implements a dual branch lake fusion deep learning network that combines text and image inputs into a single prediction. Our final model achieves 98% accuracy rate on our test set. I'll show you our project structure, do a deep dive into the architecture, walk you through the training, containerizing API deployment, and showcase how we make our model explainable using a grad cam and tokens and visualizations. Let's look. Let's first look at our project layout. The project is very highly modular. In the root directory, we have a data folder and containing the CSV files, train test and value CSV. These track text prompts pairing with target image files, paths located with respect to subdirectories to ensure producibility. We wrote data download in the scripts to automate downloading the raw datasets and placing the scripts in their correct folders. The logic core inside SRC, under SRC we have data for dataset, handling models for our network architecture, and API for serving models via FastAPI and train.python. Also, additionally, we have Docker Compose and Docker configurations and a submission.yml file which acts as an orchestrator, defining the setup, training, and evaluation commands in a clean and reproducible manner. Now let's look at the multi-modal.python, dive into the neural network architecture. We implement a dual branch classifier that tests the branch uses a Hugging Face auto model to load a pre-trained distilled word model. When a text prompt is passed through this branch, we extract the hidden representation of the token from the final layer. This output a high quality 768 dimensional textual semantic vector. In train.python, uh, let's examine this because sometimes sentiment data sets are frequently balanced. The training script computes balanced class weights using a script like scikit learns compute weight utility. These weights are then passed directly into the PyTorch cross entropy loss function to ensure the models doesn't over bias towards the majority classes. We then use an Adam optimizer with a linear scheduling warm-up for tabulation studies and train three configurations to evaluate each modality contributions. To serve our model in production, we deployed a REST API using FastAPI. Here, during the startup event, the application determines whether a GPU is available, loads the distilled tokenization, initializes the model architecture, and loads the best performing multimodal weights from our checkpoint directory. And also, we containerize this API using a multi-stage Docker file and a Docker Compose setup, enabling single command deployment with a Docker Compose.build. Here it is. You can see the Docker is running. A major highlight of this project is explainability. To build the trust in deep learning models, we must understand why they make specific predictions. In our interpretability module, we implement two methods for the visual branch. We use GradCam by Cook, registering feature maps and gradients from the last convolutional block of ResNet 18. We generate a localized heat map displaying exactly what visual areas the model focuses on. For the text branch, we calculate the token saliency by taking gradients of a class codes with respect to the input words. For example, in our positive test cases, the model calculates predicted positive with a near perfect confidence. The text saliency highlights the outstanding as the highest importance words, while a GradCam heat map highlights key objectives in the image. In conclusion, this project successfully delivers a production-ready, highly accurate multimodal sentiment analysis. They have successfully reached the class imbalance, achieved a 98% accuracy through late fusion integrated model explainability via GradCam. The entire setup, training, and evaluation pipeline is fully reproducible using a submissional YML mapping. And also, here is the step-by-step implementation or how to train, evaluate, and also run the Docker fast container and start the server. Thank you so much for your time, and I'm happy to take any questions in the comment box below. Thank you so much for watching.